How do you do, ladies and gentlemen, and teachers and boys and girls and mothers and fathers and people? I'm Julius Sumner Miller, and physics is my business. And our special business today, adventures with electric charges. Adventures. Some wonderful things, really. Consider the following. Here is a slab of lucite. I've now handled it abundantly. It is electrostatically neutral. Here is a metal plate on an insulating handle. It is electrostatically neutral. I lay the plate on the slab, and I lift it, and all I'm lifting is the weight of the plate. Now I'm going to do something. I'm going to do some work on this slab of lucite. I am slapping it with a fur. I have endowed that slab with some strange electric properties. Proof. I'm going to put the metal plate on the slab, and I'm going to put my finger on the upper surface of the metal plate, and then I'm going to lift the plate with ever so great a delicacy. A delicateness. Oh, it's very heavy. There are some electrostatic binding forces, Coulomb forces we call them, and I'll show you that I have some electric energy in this metal plate, or on it. Listen now. There was a discharge. There's a discharge. There is a discharge, and I can continue to take electric energy from this system forever, which is a very long time. Indeed, the electric energy available to me there could light a fluorescent lamp, which it may be difficult to see, but that's all right. I assert it will excite or light the lamp. Yes, I saw it. It's a little difficult in the studio with these much lights. Here is a tube called a spectrum tube. It contains some neon gas, and it takes about 5,000 volts to excite this tube. I'm going to show you that I can flash that tube. Watch it. There it is. It flashed. It flashed. So, the electrophorus, that's what that is called, an electrophorus. First put together by the wonderful Alessandro Volta in Italy, Como, Italy. Now some more on these matters, adventures with electric charges. I have here a Van de Graaff generator, and here I have a tube in which I'm going to put some cigarette smoke. Getting most of it in my eyes. That tube is filled with cigarette smoke. I'm going to connect that tube to this Van de Graaff generator, which can supply me with a large difference of potential. Watch the smoke. Watch the smoke. Will you just connect the generator for me, please, a moment? There, you see it. Thank you very much. There was a precipitation of the smoke in this flask, in this tube, which suggests that the smoke was possessed of, made up of charged particles. Now I'm going to discharge that Van de Graaff because it could be a little risky for me. Let me show you something more wonderful still. Here is a three-pointed vehicle, like a lawn sprinkler. Notice the arms are bent at right angles to themselves and sharply pointed. I'm going to put this on the Van de Graaff. The system is at rest, and we will in a moment energize the Van de Graaff, and you will see an astonishing thing. We hope that little spin wheel thing will turn. Watch it. Let me have it, please. There it is. There it is. Turning. Thank you, sir. Notice there was not much charge on this sphere of the Van de Graaff generator. Now, why? Because sharp points are good lightning arrestors, or they speedily discharge the charge gathered, which tells us why lightning arrestors are sharply pointed. Consider this, which I call the mad professor's head. Some bits of paper. I'm going to make connection with the Van de Graaff. Every little sliver will acquire the same charge. And what should they do? Watch it now. Just a minute. Hold on. Will you please energize that machine for me? Look at here. Look at that. And notice, too. Thank you, sir. Notice down there, the field is so strong as to be felt at a distance. Let me have that once more, because I like it. There it is. I think that's wonderful. Thank you. I'm going to try it once more. Hold on, hold on. I'm going to present my own head there, and I hope you will see the hair stand on end. A little, please. Oh, yes, I feel it. Whoop, whoop, that's enough. Notice we nearly had a disaster because I felt a discharge. One more matter. Here I have, notice how cautious I am. Here I have a candle flame, and nearby it a sharp-pointed rod, and nearby it on this side a spherical conductor. And I hope you see those very clearly. And I'm going to suggest the following. Here is the flame of the candle. There is the flame of the candle. Thermal energy gives rise to ionization. There are then, in this flame, produced by the flame, some positive ions and some negative ions. If I have the sharp point of a conductor, which is connected with the Van de Graaff, supposing there is an abundance of positive charges here, and this Van de Graaff is negative, do you see what's going to happen? The flame will be dragged over. On the other hand, if we change the charge on one of these, the flame will be pushed away. I'm going to connect to the Van de Graaff, and watch now. Wait, wait. I have to make connection. I have to make connection. Here I'm making connection with the rod near the flame. If you will energize that, please. Watch it. Oh, we had a little trouble. Thank you. I had a feeling that the flame was pushed away, but we're in a little mechanical trouble, which need not fret us too much. Now, consider the following. Incredible device. A Leyden jar, dissectable, meaning I can take it apart. Metal, insulator, metal conductor. I am going to charge it on the Van de Graaff, storing some electric energy in this vessel, if you will, please. Enough? I'm going to show you that there's some electric energy there. Watch now what happens when I connect the outermost and the innermost. Watch it. Oh, and there's always some more. There it is, and always some more. So we have found evidence of storing some electric charge in that vessel called a Leyden jar. L-E-Y-D-E-N, Leyden or Leiden, after Holland. Peter von Muschenbroek discovered this. Indeed, he had a shock which so stirred him that he said he would not take such another for the whole kingdom of France. Now, I want to show you something very remarkable about this vessel. I'm going to charge it again, please. Enough? Now I am going to disassemble it. There it is. I have disassembled it and connected all the parts. Would you not think that I have discharged the instrument? After all, I've connected the outermost and the innermost. Watch me now. I now assemble it. And now watch. Watch. Ho-ho! That's a killer. That's a killer. I remember when I first saw this 50 years ago, it puzzled me nearly to madness because I didn't understand it. And so I suggest that those students who understand this, they deserve an A in this subject of electrostatics. I'm going to do that again so you'll see that it's no fluke. Again, if you please. Thank you. Notice, the greater the charge on the sphere, the greater the charge on this, and I feel the hair on my arm standing on end, and pretty soon I might have it. So watch, I'm going to disassemble it. I'm going to disassemble it. Notice, with absolute abandon. No, absolute abandon. Assemble it, outermost, innermost. Watch it now. Watch it. Uh-huh. The energy is still there, and I want to know how it is that rascal works. Now, I have another one, a bigger one. This is a glass vessel, which is coated on the inside with a metal foil, so it's a conductor inside. It is coated on the outside with a metal foil, so it's just like that dissectable Leyden jar that I had a moment ago, but this one cannot be dissected. Parenthetically, you notice I pronounce the word dissected, not dissected. It is not dissection when you cut up fishes and mollusks and cats and things. The word is dissect, and the word is also bisect, but not dissect. Watch me. I'm going to store some electric energy in this. If you will, please hold it, hold it, hold it. Now, if you will, please. I would say that's enough, thank you. And I think there's enough electric energy in here to knock down a horse. Watch. I'm going to connect the innermost and the outermost. Watch, watch, watch. Oh, mother! That is incredible. That is something. I would say that could knock me down once more, because it's very dramatic. Once more. Oh, hold it, Nellie. I feel the hair on my arm standing on end. I feel my eyebrows beginning to tickle, which means that I'm getting loaded with electric charge. And now watch the energy in this system. Incredible. Watch it now. Watch it. Oh! As we say, a beautiful... Oh, I'm going to be sure. A capacitor, a Leyden jar, discharges exponentially, which means there's always some there, and one should never take a risk with it. Do you understand why it was that Peter von Muschenbroek, playing with these things in the 17th century, said, having taken a shock, that he would not take such another for the kingdom of France? So we have explored some wonderful adventures in electrostatic phenomena, and all we have done is a little work separating positive and negative charges, and a whole new world is exposed to us. And I thank you for watching.